The moon, of course, and Mars are really well-defined objects, so you can focus in a little more on that. Moon one-way trip time is approximately 3, maybe 4 days if you're taking the slow boat, and then to come back similar amount. With Mars, there's a little more variation in it, but assuming you have conventional propulsion, it could be up to 8 months one way. The nasty thing about that, though, is that because you're leaving Earth with Earth behind Mars and then arriving at Mars with Earth ahead of Mars, because Earth's in a lower, faster orbit, then you've lost the proper phase relationship for return. You can't, if you take 8 months getting out there, you're going to have to wait more than a year for the Earth to sort of come around again so that it's about to lap Mars, so that it's in the optimal phase relationship for return. So these missions to Mars can take almost 3 years, over 2 years. Granted, if you have something approaching a warp drive, you could get out there in a few weeks. You know, if you had a nuclear kind of powered propulsion, either direct thermal nuclear propulsion or possibly one of these electric propulsion vehicles that are nuclear powered, you might then be able to get out there in just a few weeks and not lose that critical phasing relationship to come back in just a few weeks, but you'd only have a week or two out there. And that actually has a flight profile or mission duration profile very similar to what NEAs or asteroids demand. NEAs are a sort of a large group with varying degrees of accessibility that you can sort of think of, and the most accessible among them is barely more than lunar duration. You might be less than 90 days round trip.